Here A divides B, 3 divides 12, but B does not divide A. And clearly B does not divide A because B is bigger than A. So if A divides B and B divides A, it has to be that, well, it can't be that one is bigger than the other. So the only way this can happen is if both are the same size. So that leads us to a conjecture that A divides B and B divides A if and only if A is equal to plus or minus B. They have to be basically the same size, although negative signs are permitted. Okay, so in other words, negative 3 divides 3 and 3 divides negative 3. We have divisibility for negative numbers as well as positive numbers. Okay, this is an if and only if. So suppose that A divides B and B divides A. Well, if A divides B, then I can write B is equal to A times C for some integer C. Also, if B divides A, then there's some other integer D such that A is equal to B times D. So I can now substitute this A into here so that B is equal to B times D times C. Now, one of two things happens. If B is not equal to 0, then I can cancel so that D times C is equal to 1. If B is equal to 0, then obviously I can't cancel, but B would be equal to 0. So one of these two things has to happen. So there's B times 0, B could be equal to 0, or if C times D is equal to 1, there's only two things that can happen. Either C and D are both equal to 1, or C and D are both equal to negative 1. And the reason I can go from here to one of these two statements is because that C and D are integers. The only two integers that when you multiply them together and get 1 are 1 and 1 and negative 1 and negative 1. Any other pair of integers will give me a product that's bigger than 1. Or if I have 0, I get something that's less than 1. Okay, so I have three cases. If B is equal to 0, then from up here, if B equals 0, then so is A. So A equals 0, B equals 0, so that A equals B. That's case 1. Case 2, if C is equal to D equals 1, if C and D are both 1, then if I plug in D equals 1, I get A is equal to B. And if D is equal to negative 1, then up here, I look at the definition of A, either C or D, and so A will be equal to negative B. So either way, A is equal to B or A is equal to negative B. So that's one implication. The second implication has two parts, either A equals B or A equals negative B. Well, clearly, if A equals B, then A divides itself and B divides itself. If A equals negative B, then A divides negative A, and negative A divides A, and so that is also correct. So that proves our theorem that if A divides B and B divides A, that happens if and only if A equals B or A equals negative B.